Hello, welcome. I'm kind of pleased, but also slightly terrified to see so many people of you here in the audience. This is a brand new talk I've never given before, so that's great. You get to see a brand new talk that's never been given before. The bad news is I might overrun, it might not be very interesting, and any feedback welcomed. Be nice. Last year, probably in this very room, I gave a presentation here about Java 8 in anger. And it was building up a brand new application using Java 8 and using lots of features from Java 8, including Lambdas and streams and Java effects, and a bunch of new features like that. And it kind of showed how to think in terms of Java 8 to build a new application. Now, the reality is that many of us are actually working on Java 6 or Java 7, and we're not getting to work on a brand shiny new application or even a new service where we get to do these things from scratch. And what I wanted to look at is, in the real world, which most of us live in, how do we try and take advantage of new features in Java 8 or new shiny Java 8-ness and apply it to our old code? I'm not going to use the word legacy because it's code that works perfectly fine. It's just that it hasn't been refreshed. Okay, so that's kind of where I'm coming from. Who's working on Java 6 applications at the moment? Chunk of you. Who's working on Java 7? Loads of you. That's interesting. Java 8 people? The sum of those three things is equal to greater than the number of people in this room. Okay. Who's working on, oh, right, that's a good point, multiple projects. Who's working on Java 6 style code but using a Java 8 compiler? There's a few of you. So the whole point here is to take real code that we work on, Java 6 style code, and see what we can do, see what we can make use of in Java 8 to improve our lives. Before we do that, I think we need to take a step back and say why. Why do we want to use Java 8? Because, well, most of you want to use Java 8 because it's new and shiny. New, it's 2 years old. For us, it's new and shiny, and we've not used these new features. But what you want to do is, if you want to sell your boss or the management or the business on refactoring existing perfectly fine code, you need to have a good reason as to why you want to make those changes. So I think probably the most compelling reason for people who aren't developers is that, generally speaking, it is faster. At the bottom, I've got a link to a bunch of references for this, which I may or may not have updated in time, but it will be there. Generally speaking, when you migrate to Java 8, your code will generally be faster, depending on what the application, blah, blah, blah. So there are some performance improvements on common data structures like HashMap. So for some of these changes, you don't even need to change your code in order to get advantages of the extra speed of Java 8. There's some speed improvements in fork join, there's some extra stuff around concurrency, and there's a bunch of other bits and pieces, just some small things which will make your code faster, even if you don't take advantage of the new features. Kind of related to that, Java 8 is easy to parallelize, which is, hopefully we'll see, is a bit of a double-edged sword. But by using the magic parallel incantation, you can run your operations on a data structure, taking advantage of multiple CPUs without having to worry about spinning up new threads or using the fork join framework directly. So Java 8 gives you the ability to parallelize some of these big operations, particularly for things like big data type problems. Probably something which is kind of more interesting to developers is this whole fewer lines of code argument. And for me, as someone who's worked on Java for a long time, more than 10 years, fewer lines of code didn't mean that much to me because we're used to working with Java the way it is. It's a bit heavyweight, there's a bit of boilerplate, you get used to ignoring it, or you make your IDE make it go away. But it does make a difference using some of these new features to collapse down some of that noise and just focus on the things we're actually trying to achieve when we're trying to write our application. There are also some features which help us to minimize errors. Kind of namely, optional is sort of designed to help you get rid of null pointer exceptions so that you return empty values which are intentionally empty rather than returning a null which may or may not be intentional. But there's also things like, and we should see this throughout this presentation, by using things like Lambdas and using some of the stream operations, we can be more intentional in what we're trying to, our code can be more intentional in what we're trying to achieve. And we can take away some of the common boilerplate things, wrap it in a method, and perhaps inject a Lambda into that method rather than have that copied and pasted all over the place. And I'll show you an example of that. But the whole point here is that some of these new features are designed to minimize some of these stupid errors that we get regularly, like null pointer exceptions. So now that you've done your sales pitch to your boss to say it's faster and we've got fewer errors, sorry, let's take a look at the safety precautions you need to have in place before refactoring. This is a talk where I will vaguely talk about some of the good practices around refactoring generally. And by refactoring, what I mean is reshaping small pieces of code to do exactly the same thing that it did before, and in theory have no impact on functionality. I don't mean rewriting, which is what a lot of us do when we actually refactor. But I will go over I will try and reiterate some of the good practices we need to have in place in order to safely refactor. Excuse me. Firstly, and most importantly, before making any changes, any non-breaking changes to our code, we should have some test coverage to prove that these are non-breaking changes. It's all well and good. This is all the XP thing, right? Be courageous and have no fear. It's very easy to have less fear around refactoring if you've got tests that were green to begin with and carry on being green afterwards to prove that we haven't broken anything. So before you start refactoring anything, you really should have some tests in place. It is possible to look at an area of code that you want to refactor and at this point write some tests for that area of code and then refactor it. But when you write tests for code afterwards, you quite often miss some of the subtleties of what it was supposed to be doing. It's just worth reiterating because I can't imagine refactoring something without having some safety net to make sure I didn't break anything horribly. If performance is important to you, it is a good idea to have some performance tests in place too. But I don't necessarily just mean the sort of low latency, high performance trading type applications. I mean things like Android applications where there's a performance implication to the user on the handheld or calls to the server. I mean things like web applications where a user shouldn't be hanging around for longer than like 0.1 seconds, right? Otherwise it looks slow to them. So whether you're working on a low latency application or whether you're working on something more, less low latency, you probably do have some performance requirements somewhere. And if you do have those performance requirements somewhere, you should probably have some tests to make sure that you don't seriously impact your performance by doing things like refactoring. You should decide on the goals of your refactoring. Like I said, there are a number of benefits to using Java 8, including better performance, greater readability, fewer errors. Have an idea in your head of which goals you're trying to achieve, which goals you're meeting by doing your refactoring, so that when you've looked at the changes that you've made, you can evaluate, has that met your goal? Is it easier to read? Is it more performant? Because otherwise, you're just basically moving code around for shits and giggles, really. And not that I've ever done that, no. It took me a long time to write this talk because I did a lot of refactoring and afterwards I was like, oh, well, I was just kind of getting carried away with rewriting the code without really thinking about what I was trying to achieve. So that's more of a note to myself, try and remember what you're trying to do. And I cannot emphasize this enough. Limit the scope of your changes, preferably to like within a method, maybe within a class. Some of these features, the changes kind of like get out of control all throughout your code base and they kind of replicate all over the place. And instead of like checking in a couple of class files where you have an idea of what the impact might be, you've checked in 6,000 class file changes and you're not really sure what went wrong where. So try and figure out a strategy to limit the area, whether it's limited to a method, a class, a package, a subsystem. Do try and carve off small chunks, otherwise you will end up getting carried away with it. So enough of that. The project we're going to be refactoring here is a real live project with real live code, because I could show you a bunch of toy examples, but it's not really, I said that this is supposed to be a sort of real life talk about real code. So we're going to use a real project. There's a number of reasons I've picked this one. One, I used to work for MongoDB, so this is actually the last piece of code I was working on at Mongo. Two, so I know it quite well. Two, it's open source, so you can take a look at the code itself. Three, it's kind of small enough and contained enough that there's some decent examples in there that you can kind of get your head around. But four, it's an old enough piece of Java code that there's some kind of like, code that's evolved over time that could be optimized, and that's kind of very indicative of a lot of the applications we work on. There's always some code somewhere which over time has been added to, and it's not quite as pretty as you would hope it was. And Morphe is quite a good example of like a real-life Java program. So let's get straight on. I'm just trying to avoid getting to the live code bit because it always goes horribly wrong. Let's go straight on. Firstly, what I'm going to look at is Lambda expressions. I'm going to cover mostly Lambda expressions and streams. Those are kind of the main ticket items, if you like, with Java 8. So those are the main areas we're going to look at. So the first thing we're going to do with Lambda expressions is try and find the places where we can automatically refactor our code to take advantage of Lambda expressions. I'm not going to spend a lot of time explaining what a Lambda expression is or why it works a particular way. There'll be some resources in a link at the end of it, which hopefully should point to more, this is Java 8 type stuff. This is more kind of, I vaguely know about Java 8, how do I Java 8 my code? So there's less teaching about what a Lambda expression is. So without further ado, let's get on and look at our code. So what I've done, let's see if I can bring up something which is readable. Ooh. I'm using IntelliJ because I work for JetBrains, but IntelliJ inspection, sorry. The other IDEs do provide a lot of these features. It's not just you should use IntelliJ because it's amazing. I happen to be using IntelliJ as my tool to locate places where I can migrate the code to Java 8. NetBeans and Eclipse do have a bunch of these features too. So it's not just a case of, oh, look at us, we're so amazing. It's just that I thought if I went through it in 3 different IDEs, it would take a long time. And IntelliJ has inspections, and inspections will basically point out bits of your code which could be changed. It's not necessarily bits of your code which are wrong, but like if you want to move your code in this direction, this is how you could do it. And so I've picked a bunch of Java 8 inspections specifically here. You can't read that very well, but that says Java language level migration aids. And what I've done is I've ticked pretty much anything which says anything about lambdas and streams. I also have some inspections selected around unused code, because once I start refactoring things, I should find some unused code which I can safely delete. So now that we've got that going, I've run the inspections already on my code base, and I can see, I promised that I wouldn't let anything go at the bottom of the screen, didn't I? Let's bring that right up in the tiny text. I can read out whatever I want, really, and I could be lying because you can't read this. So it says Java language level migration aids. There's some places where we can make changes to move this to Java 8. So we've got anonymous type can be replaced with Lambda. We've got for each loop can be collapsed with a stream API. We've got a bunch of other things. While loop can be replaced with a for each. And so we're going to go through just a couple of these things. First, I want to start with anonymous type can be replaced with Lambda. And I can take a look at some of these places. So the code that I've got this is the kind of thing that we expected Lambdas to be able to help us with. We have an anonymous inner class, and in Java 8, this can be lambdaized. And with IntelliJ, I can use magic Alt-Enter and tell it to replace it with a Lambda. I just got rid of all of that code and shrunk it down to a single line. Okay? So what we did have was all of this gray is all the kind of boilerplate we didn't really care about. What you will notice, of course, is that with the Lambda, we lose a lot of the type information. Well, the type information is still there. It's just not kind of explicitly said. So we don't know that it's a predicate. We don't know that it takes a string and returns a Boolean. But your IDE can help you out with some of that. So here now we have a little Lambda icon on the left-hand side. And what it says there is overrides method in predicate. So if you want to, you can then follow that through to find out which functional interface the Lambda is an implementation of, if you like. So that was kind of fairly straightforward. And in many ways, with some of those refactorings, I can just kind of apply that as long as it looks kind of vaguely sensible and move on. I don't have to analyze it too much more than that. Let me go through a couple more examples. So another good example is runnable. So anywhere where we're passing a runnable into an executor service or an executor service. And so we can shrink that down to a Lambda as well. Let me put that down there so we can see it. And so now, instead of being our full runnable, we just have a small Lambda. And that's kind of where Lambdas are really quite nice and sweet. Let's also static import these. So we shrink it down to get rid of everything that's not really important. So this is kind of what we're talking about when we talk about, reduced boilerplate, potentially increased readability once you start getting used to reading these things. And it's not super exciting, but it's kind of nice to get rid of all the clutter on your code. My final example here is we shrink the callable down, and then this gets shrunk into a 2-line Lambda. So it's not just a single line. Again, we're kind of reducing some of the boilerplate that we don't really need. Okay, fine. That's not super exciting, but it's quite nice. It kind of gets rid of redundant stuff in our code. So let's move on to something a bit more interesting, I guess, hopefully. Abstract classes. Lambdas are implementations of interfaces with a single abstract method. And it has to be an interface. What we might find is that in our code, we might have some abstract classes which can effectively be converted to interfaces that might be interfaces with a single abstract method. And we can find these in our code as well. Let's have a look here. I've got class structure here. Abstract class may be an interface. Let's have a look at it. Here I have an abstract class, and it's got a single abstract method on it. So I can convert this to an interface fairly safely. I haven't really changed anything. I will do that. Convert class to interface. It turns that into an interface. And if I want to, then I can add the tag of functional interface to that, and then I can implement this as a Lambda. So if I go to an implementation of this, this was originally another anonymous in a class, obviously, and I can shrink that down to replace that with a Lambda. Okay, I can also make use of the diamond operator to get rid of that. So again, I'm just kind of getting rid of some of the boilerplate, retaining a lot of the functionality, getting rid of the boilerplate. I'm not going to go through all of those specific examples because you get the idea of you can convert your abstract class to an interface, and then you can start using Lambdas. And then finally, so those are all kind of fairly automatable. There's another thing you can do where you can search for particular patterns of your code which might benefit from using Lambda expressions. So this is where we start to get a bit more complex. So what I've got is I've got a structural search, If I open that up and hopefully it's readable. Yeah. What I want to do is I want to find all instances where we're logging a message. So I'm going to find any call on log of any level with a message, and I'm going to replace it with a Lambda. And I'll show you why in a minute, hopefully. So I can basically do a search and replace across my code base for this. So let's find an example. I'm doing that as part of my inspections, so that gets flagged as part of my problems in my inspections as well. I've called this one log should be lazy. So here I have a debug statement. And what the debug statement is doing is, well, let's say our log level is not set to debug, which generally speaking it's not. We're still having to create this string. We still have to concatenate those two strings. This stages is actually a list. So we're going to go into the list, iterate over the whole list to create the string representation of the list. We're going to append that to this string stages, and then we're going to do absolutely nothing with it whatsoever because our log level is not set to debug. So we've just done a bunch of work for no reason whatsoever. So what I want to do is I'm going to replace this with my lambdaized expression. I'm going to get IntelliJ to create this method. This is on an interface called logger. And this is going to take a supplier, spelled badly, supplier, string. Let's call it string supplier. And this is an interface with a bunch of different implementations. I'll do it up here so you can see that better. There's a bunch of different implementations. But this method, I actually want this method, I can provide a default implementation of this method, which will do the same thing for all of those implementations. If they want to override it, they can, but I know what I want my default functionality to be. So let me scroll that up a bit so you can see it a bit more. Let's turn this into a default method. Remember that this is an interface, but you can do this now in Java 8. Add a method body, and I'm going to say if debug enabled, then call debug with string supplier dot get. Okay? So I can add a method body onto my interface, and this is kind of, as the name suggests, a default implementation of the log method. And only if the debug level is set do I build that string. Okay, only if I have to use that string will I go away and build that string. And I can do that. I can apply that across the board for all of my log messages. And I'll show you why that's a useful thing. One is performance, and I can show you some benchmarks of that in a minute. But two is cases like, let me find the right one, data impl. Cases like this. When you put, this person correctly tried to encase the log statement inside an if statement to make sure that cost wasn't incurred when you don't have the right level. But not unusually for copy-paste coding, we've got a check for is trace enabled and an actual log.info. So there's a mismatch there between what you're actually trying to achieve. Now, if instead you're going to be doing this, and you can get rid of this, you can get rid of this, and your log.info method has the right if statement around there, you minimize the sort of copy-paste errors that you get around your code. And that's because you can inject that lambda in instead of having to put the if everywhere in your code. One of the other interesting things about this is this lambda doesn't work amazingly well. It says here, variable used in Lambda expressions should be final or effectively final. Okay, because dbcol is not final and it does change potentially. So then when you've got something like this, then obviously you need to do some refactoring around that. I need to make this the database name, collection name actually. And then move that outside of there. And then I can have that in the Lambda. Okay, so you can use your normal refactoring tools to improve that. So that's kind of, that's some of the basics of applying Lambdas to our code base. Some of the advantages there. Some of that stuff is kind of super automatic. Some of it requires a bit of thought from our point and some manual searching. And I would say that to some extent, the gains from doing that refactoring is kind of loosely related to the amount of effort you're going to put into that refactoring. Let's look quickly at collections and streams. Quickly, maybe not quickly. Again, we have a bunch of automatic refactorings we can use here. So we can, with the Lambda expressions, we can take a bunch of code which looks fairly different, anything which is kind of interfacey or anonymous in a classy, and turn that into a Lambda expression. With this automatic refactoring, we take anything which looks like a for loop and we can turn it into a bunch of different things. And IntelliJ will figure out what is the right pattern for this particular piece of code. So if I have for loops with if statements, it can decide if it's a for loop which turns one collection into another collection, it will replace it with a collect statement. If it's a for loop which iterates over something and does something, it will replace it with a for each. And one of the other interesting things is that in Java 8, the for each method is not just applicable to streams. If you have a collection, there's a for each method there. So, for example, if you have a list, you can do list.forEach instead of list.streams.forEach. And the automatic refactorings will figure out which one is applicable for your circumstances. So that's quite nice. You don't have to think so much about that. Let's take a quick look at those examples. Ooh, let's get rid of that. So the inspection that we're looking at here is for each loop can be collapsed with Stream API. I'll start with a nice simple example. Here we have, this is kind of fairly standard code that you probably stumble across in all sorts of code bases. What we have is we have a list of keys. We're iterating over that list of keys. We're getting out the ID of that key and putting it into another list, and we return that list. So we start with a list of keys, and we return a list with a list of IDs. IntelliJ is suggesting that I can replace this with a collect statement. So what we do instead of what we were doing before is we use streams, we map it using the ID, and we collect it into a list. Again, I'm not going to go into too many, that's not what I wanted, too many details about how and why, but that's the operation that we want. We were going over a collection, taking out one field and turning it into something else. And then I have to look at the rest of the code, and I think, well, actually, we were initializing this array list with some arbitrary size. I'm going to hope, and I'm going to performance test if it matters, that that's an optimization that either streams can take care of or doesn't matter that much. And then what I can do is just get rid of that, because what we were doing is this stream operation is returning a list, and then we're putting all the items from that list into another empty list. So that seems like at least one list too many. So I'm going to get rid of that intermediate list. And in fact, we can get rid of that completely and just say, return that. Oops. So now, reformat that. We've gone from a for loop where we iterate over a list to a single stream operation. And if we format that so it's a single line of code, it can be a single line of code. So we just simplified our code straight away. That's kind of one of the simplest examples, which is kind of fairly safe to apply. Let's look at a somewhat more questionable example. Here we have a lovely piece of code where we have a for loop with a for loop and an if statement, and we've got a set up here, and we've got another set down here, and we have a bunch of intermediate collections. So let's see what IntelliJ does with this. That turns it into a collect statement as well. It changes the if statement into a filter, and we do this map operation as well. But really, and we still have this original for loop here, we still have a bunch of intermediate collections. It's quite difficult, if we do a comparison, in terms of lines of code, there's not a lot of difference in terms of the lines of code. We're also mixing two kind of idioms, one for loop and one stream. So at this point, with this sort of refactoring, you can look at that and think, okay, I'm happy with that because I'm going in the right direction. I'm using more Java 8 type features, which is kind of where I want to go. Or I'm unhappy with that because I feel like what we've got there is a bit of a confusing mess of different ways of doing things. So we can either apply that or decide that actually the fact that we can't easily refactor this implies there might be some other smell or some other design which might work better for us. In this particular case, I think part of the problem is that we have a set which is being passed in, a temporary set up here, and then we're kind of iterating over these two things in slightly different ways. And we also have a list of fields, and so I suspect there might be a different way to sort of shape all that data so you can do it all in one single pass instead of having it to iterate over multiple collections. But that's something that is not automatable and is going to require a human brain. So at this point for me, I would probably make a note of this as some sort of tech debt which may or may not be cleaned up at some point. Okay, let's have a look at some other examples. So this one is this is why this code base is actually quite good for using Java 8 stuff, because we do quite a lot of iterating, quite a lot of if statements and stuff, and they all do interesting things. What we've got here is we have a list, we have a for loop, we have a sort operation, and we have another for loop. So let's see how we can refactor this. We're going to replace this with a collect statement again. This is similar to our first example. We're just going to map. We're going to turn one collection into another using the map operation. OK, so what's my next step? Then I sort that list. Well, I don't need to take this list and sort it now. I can sort it as part of the stream. So I can just say, OK, I want that to be sorted. So I can remove a whole operation. It just kind of gets done as part of the stream operation. Then I look at this and I say, OK, well, what happens to my list of log lines? Well, then I iterate through that list of log lines, and I print it out. I log each one of those log lines. So I think, well, OK, instead of going through, iterating through this whole list of violation exceptions, constraint violation exceptions, instead of iterating through my list of exceptions, turning them into another collection, and iterating over that collection, and then outputting the items of that, I can just skip that whole step. So instead of doing a collect, I can do a for each. And I can take each one of those log lines and I can log it. I'm going to get rid of that there, bring this up here, figure out what I've done wrong here. And then I don't need this intermediate collection because all I've done is I've done those three operations, the initial loop, the sorting, and the final printing loop in a single stream operation. And this, I think, is where streams are going to be very interesting, because you can do it all in just one pass. I really, really wanted to performance test this, and I didn't get a chance to get around to it. But I'd be very interested to see what the performance of this is compared to the old version. I did something to... So that's quite a nice example of multiple operations shrinking down into a single stream operation. And I have a counter example, of course, of... let's have a look at this one. I have something kind of, well, not really similar. I have another for loop over a list. What I can do here is I replace this with a collect statement again, so it maps it, collects it. What can I do with this? Can I shrink down the rest of the boilerplate around here? Well, again, this looks like perhaps an optimization which I can get rid of. I don't need to initialize the array list with a size. So I can get rid of that intermediate collection. So now I think I can just assign this streamed collection directly to that one. Now what happens to this? Then I'm going to turn it into an array of strings. So that implies to me I should be able to do toArray with a new string, size whatever. What did I do wrong there? There's probably an automated way of doing this, and I don't know what it is. And then I can just use my strings directly here and pass that in. And then inline that because then we can remove another line of code. What have I done wrong? Oh, because this doesn't work. So I have reduced my lines of code slightly. I've reduced it down to what looks like a single operation, the same way I did last time. But it's not a single operation, because this collect statement is the end of our stream operation, and this toArray is an operation that happens on the final list. So I'm actually doing two operations there. But it's not obvious, because this dot thing, oh, come on, where have I gone now? Go back. This dot, there's no indication of the difference between a dot which says the next method is going to do something versus a dot which is kind of like I'm building up my operation and it's going to be all evaluated at the end. So you have kind of, when you look at these sorts of things, you have to really understand what is going to incur a cost of going away and doing something, and what is merely just building up the sort of recipe of that operation. So here we still have two operations happening. And that's not necessarily a bad thing, because you've still got potentially the same performance that you had before, but you're not getting quite the wins that you think you might be getting. So you have to be aware of what's going on under the covers. And finally, have we got time? Yeah, we've got time. So those are kind of the automated refactorings. With these stream operations, as you've seen, I've kind of taken the automated refactoring, the default. Then I've looked at the code around that to find out whether there are some further steps that we can do. So I don't just apply them across the board. I'm kind of going to use my brain and say, OK, now that I've done that refactoring, what does that allow me to do next? Can I shrink things down even further? But there's also kind of more manual steps that you can take even further to try and simplify your life. So if we look back at one of the examples we looked at in the Lambdas, where we turned this abstract class into an interface, this is used by a method further up here called loop map. I'm not going to go into the details of this because it's kind of ugly, but that's the way it goes. It's ugly by necessity. But if we look at where this is being used, look in decode. What loop map is effectively doing is it's taking this object, which is a map, and iterating over it with performing what's in this lambda. Well, that sounds kind of deeply suspiciously like something that could perhaps be a for each. So if I extract this out into a map, I'm going to cast it into a map. It happens to be a map. I had to do some actual thinking and analysis to figure out what sort of object it is. Morphia does mapping from database objects to real Java objects, so we can't get around the fact that sometimes what you have is an object, not a map, not a nice Java object. It's just a plain old object. We have to do a lot of casting. That's kind of, unfortunately, kind of part of the purpose of Morphia. We can't really get away from that. But the analysis of the code here shows that at this point in time, this object is a map. So then once I have a map, what can I do? Well, I can iterate over. I can do a for each with, that's going to be my key, and that's going to be my value. And then I can do the same thing here with map.forEach. From the calling code point of view, we, apart from originally getting rid of the anonymous in a class, we haven't really, it doesn't look like we've really saved a lot of time and effort. But what we have done is we've managed to completely get rid of this method. We don't need it at all. We can just delete that and just use the Java 8 method instead. And we can perhaps make some assumptions about the fact that the Java 8 method may be more optimizable or maybe cleaner or more easily updated with different versions of Java rather than us having to maintain our own version of for each. Deleting code is always fun. Anywhere I can delete code, I'm going to assume that's a good thing. Okay, so that's kind of the two main areas of Lambda expressions and streams. So we kind of see the what's going on? My computer's trying to sign into Hangouts. I think someone's trying to talk to me. Get off the stage. So we can see there's a range of refactorings which are very easy to apply automatically, should have relatively low impact maybe. Some places where we have to do particular types of searches to find examples of that sort of thing. One of the places I was really, really keen to apply a new Java 8 thing which kind of should change the way we think, especially for library code like Morphia, or I also used to work on the MongoDB driver, is optional. So this idea of being able to intentionally return something which is empty, that doesn't have a value, rather than returning null and the calling method having to figure out, well, null means it's not there, so I have to do null checks. So I was really, really keen to get a good example of what optional looks like when you start using it in your code. Unfortunately, what happened was I ended up changing like 50 classes, and at the end of it, each one of these had this sort of thing where I had to add optional of nullable, and all of my fields, all of my variables just go into an intermediate state of just being a big fat mess of optional. So I would say the lesson learned from optional is I'm not sure you can retrofit it. If you can, do it very carefully. Do it one class at a time. Don't let it crawl all over your code, and constrain it to just return types of perhaps a public method, because you can get into a big hairy mess there. For creating new code, especially for things like public APIs, I think optional is a really good way to go, because you can define whether that should return a value or not. For example, find one. Sometimes there won't be one, so return an empty optional. But for an existing code base where perhaps your own understanding of what's null and what's not null is kind of hazy, because I found a bunch of null checks in the code, and yet it's difficult to tell whether it really can be null or has been checked further down the line. It's, don't go there. Most of this talk I spent trying to refactor optional, and so for that reason I had to have a slide about optional. Don't do it, kids. Anyway, so I've got 12 minutes left. Great. What about performance? We kind of implied that Java 8 has better performance, generally speaking. Also, something like streams obviously has a different way of thinking, if you like, a different way of operating, so has potentially a potential impact on the performance of your system. Lambdas, do they perform differently to anonymous inner classes? What does this do to the performance of your system? So what I wanted to do is I wanted to take all the different questions around lambdas and streams, and I wanted to show you, in these cases, you should do it because the performance is better, and in those cases, you shouldn't do it because it's worse. And then I realized what I was doing was performance testing Java 8, and I stopped that. So what I've done is I've just taken a few examples of the code that I've just shown you, performance tested those to give you an idea of the minefield you're starting to tread into. Firstly, let's look at lambdas. So the lambda example I showed you, where I turned that abstract class into an interface and then turned the implementers into a Lambda. I performance tested that versus the original implementation, which is anonymous in the class. I've had to put the smiley faces and sad faces because my charts are, oh, things gone off the bottom. My charts are kind of, some of them, the high numbers are better, and some of them, the high numbers mean lower performance. In this chart, a bigger number is better. We get more operations per millisecond. And the red one on the right, that's Lambdas, because my legend has gone off the bottom of the screen and you can't see it. So Lambdas perform marginally better than anonymous inner classes for my one specific example that I tested in terms of that anonymous inner class. However, I then went to go away and find out if someone had already done all this performance testing so that I didn't have to. And of course, Oracle have done this. So there's a whole presentation. I'll send out a link later on at the end of this presentation. There's a full link at the end of the presentation to all of this stuff. So you can't see that at the bottom, sadly. Oracle's got a whole presentation on the performance implications of different types of Lambdas, calling it at different times with warm up and not warmed up and so on and so forth. But just for one example, here, a higher number is a bad thing, so it's slower performance. You can see that in some cases, the Lambda, which is the red one, outperforms the anonymous inner class, and sometimes it doesn't. So the answer there is, are Lambdas better performance than anonymous inner classes? Sometimes. It depends. Okay, fine. Let's look at our use of Lambdas where we put them into the logs. And you remember that if we didn't use a Lambda in the method call, we have to do all the work of constructing that string. Well, that work of constructing the string is that tiny red bar down there, where low numbers are bad. So it's substantially more expensive to do the cost. And that's I was testing just a single string with a single concatenation of one variable, not a complicated thing where I was getting a list and checking all of that. The cost of creating that string, especially when you don't need to log it, is pretty high. And I can tell you from experience of performance testing a set of library code, that impact on the library code was substantial. And when we wrapped all our log files, all our log calls inside an if statement to check that we were at the right log level, it had a big impact on our performance. So here, using the Lambda-ified method for log had a big impact on our performance, a positive impact on performance. Okay, so Lambdas, it depends, obviously. Streams versus iteration. Is it better or worse to use streams versus for loops? I used the same example I used before. That loop map method, which I deleted, that had a for loop inside it. And when I compared the performance of that versus the stream version of that, the performance was more or less the same. But this, again, it depends. If your for loop is working over primitives or iterating over arrays and stuff like that, it's going to be much more performant than creating a stream, which is much more heavy in terms of objects, and also depends on what you're doing inside that for loop. This was doing quite a complicated thing inside the for loop. So the cost of the for loop versus the cost of the stream is negligible versus the cost of the operation inside that for loop. So again, it depends. And again, the Oracle numbers have got some numbers on that too. So going parallel. I didn't show an example of going parallel because I hadn't found any code where I definitely want to perform one of those stream operations in parallel. I have done some analysis on the performance of this before. So here, there's a map operation. We had 46,000 items in our collection, and I want to do a map of that collection of objects to a list of names of those objects. So I have to parse the whole list to turn it into a whole another list. Doing that in serial takes longer than doing it in parallel. Well, that's kind of what you expected. Except that I had to have over 40,000 items in my list before going serial was slower than going in parallel. And if you're doing a different type of operation, like find any, where you just return once you find the first version, serial can do it in like 20 milliseconds on a laptop, and parallel is like 120 milliseconds on my laptop. Parallel was substantially slower for an operation like find any. So parallel is not your magic incantation which will make things better. This definitely needs to be performance tested to find out if it's doing what you think it's doing. Optional because, I'm played with optional loads, and I wanted to know, optional seems like a good idea, but obviously there's an extra object there. There's an optional object there. So what are the costs of that? Optional has the idea of doing is present, versus doing an old-fashioned null check. So I checked if you've got a constant value and you're doing a comparison with null, how's the performance of that versus doing an is present on optional? And not surprisingly, it's more or less the same thing, because is present on optional is just a null check. However, if you're also wrapping that value in an optional, the cost of that object creation of the optional is a cost. So it's substantially slower if all the time you have to wrap your object in an optional and then return it to someone else. So there are costs there around object creation. So, in summary, what I wanted to be able to do is I wanted to be able to say, these shapes of refactorings are fairly safe, you can do them automatically, and they will give you better performance, and everyone lives happily ever after. And these shapes of refactorings are more dangerous, or potentially need a lot more effort, or are going to degrade your performance, or so forth. Of course, things aren't that simple. Sometimes the new idioms will decrease the clutter. So sometimes lambdas and streams will decrease the amount of code that you have. For example, when we did our mapping of keys to IDs, we reduced the amount of code and arguably depends a bit on getting used to it, but retain the readability of that code. Great. That's what Java 8 is supposed to do. Sometimes using the new idioms doesn't necessarily gain you anything in terms of readability or in terms of decreased number of lines of code. For example, here, where we converted a for and an if to a filter and a for each. And it's effectively the same thing. So you've got almost the same number of lines. You've actually got slightly more on the Java 8 version is on the right-hand side. You have slightly more lines of code there. So we didn't really gain anything in this particular example. Unless what you wanted to gain was, we should use Java 8 more to figure out what Java 8 looks like and see if we can simplify some of our operations. Sometimes the new features improve performance. In my specific example of lambdas, I got marginally better performance from having lambda. And sometimes you don't get better performance. For example, if you wrap your value in an optional, you have just incurred an extra cost there. Sometimes your new feature makes life easier. For me, the whole log thing is just such an easy win for improving both your performance and reducing this copy-paste error that it's a massive win. But sometimes you don't get the benefits that you wanted to get. For example, optional. And maybe it's just me, maybe I have not figured out how to use it the right way, but going back and retrofitting optional when you don't understand the impact of nulls in your system is a very difficult thing to do. Some refactoring can be done automatically by your amazing IDE, whether it's IntelliJ, Eclipse, or NetBeans. So we can shrink down our anonymous inner classes to lambdas fairly easily without worrying too much about any changes there. But often, to get the most benefit from this, you really do need to use your brain. I mean, that's what we do as developers. So here's an example I didn't really show you, but I managed to collapse all of this code down to 3 different operations. And also, once it's collapsed down to those different operations, I can sort of see that perhaps we should be rethinking the way these collections are arranged, so I can just collapse all that down to one more. But the IDE didn't tell me that. I had to do that all manually. So, in conclusion, should you migrate your code to Java 8? The answer is, it depends. Of course it depends. That's our whole job. That's what we do, right? It depends. You have to remember what your goal is. Are you trying to make your application perform faster? Are you trying to aid readability? Are you trying to do things that you couldn't do before, use design patterns that you couldn't use before, for example, by using lambdas? So remember what your goal was and compare your results to that goal. Does it make it faster? Is it more readable? Understand, have a vague idea of what things might impact performance. You don't have to understand by looking at the code, oh, this will make it 3 times slower, but understand what may impact performance. For example, knowing that a stream is a single operation or there's a series of operations nested in there that's kind of hidden away. And if you don't really know what the impact is, then measure that so that you can know. Your code may magically improve with some of these automatic refactorings. More likely, I think it's going to expose areas that you might want to refactor in future. Or leave well alone because it works and you are just doing this to try and get some quick wins anyway. And your tools such as your IDE or various other inspections can help you, but you really do need to think hard about what you're trying to achieve. Does this look better? Does it meet my goals? Can I do this better and simpler? Does it perhaps imply that my design was incorrect to begin with and I need to redesign this whole area? So, all the resources should be available at that link. Certainly the links to the performance tests and links to some articles about the pros and cons of Java 8 are in there. Chances are pretty good that this afternoon I will go and add more things into that. But that's where all the resources for this will be. I will also upload these slides to that. And if and when this is videoed, I will add the video onto that as well. I have 1 minute for questions. Yes? What about impacting team morale? Oh, I like that question. That's not a 1 minute question. No, but I think that's a good idea. When it comes to your goals, are your goals to keep your team happy? Are your goals to help upskill your team? That could be one of your goals. And if that's the case, then doing some small refactorings towards Java 8 that are not dangerous, they don't impact functionality and don't seem to do terrible things to your performance, then I think that's a perfectly acceptable reason to be migrating to Java 8, as long as you don't impact your delivery to the business. It says my time is up, so if you have any questions, ping me over Twitter. Thank you very much.